Hello everyone, I'm Hetvi Ambasana. Welcome to the portfolio video of second semester studio construction project execution monitoring and control for construction engineering and management course at SAP University. In the second semester studio of the program, I've undertaken the study of mixed development project. For this portfolio, I will start from general project details. This project is located in the state of Gujarat. It is located in the Ahmedabad city near Panjrapol Crossroad. The project is divided into 6 blocks, namely A, B, C, D, E, and F. Block A, B, and E, F are G plus 13, while block C, D is G plus 14. The blocks A, B, and E, F have commercial up to second floor, and from third floor it is residential. The total area of the project is around 2.01 acre. It's a residential cum commercial type of project. Total open area is around 52,000 square feet, while total built-up area is around 6,57,000 square feet. It's an item rate contract, while the payment is on square feet basis. Topic is triple role concept. As per J.M. Juran, in every complex construction, each and every party involved have majorly three roles to play. One as a supplier, second as a processor, and third as a customer. This process is called triple role concept. As you can see below, the first step in the triple role concept is to identify major stakeholders involved. Next is to define the roles and responsibilities as a supplier, as a processor, and as a customer. Third step is to prepare the CPOC process mapping, which you can see in the right side table. The last step is to represent it in a CPOC diagram. Now CPOC is a measurement tool used to represent the triple role concept. As you can see in the right hand side table, the end user will provide the list of preliminary requirement to the client in form of project brief. Here, the end user is the supplier while the client is the customer. Hence, for every stakeholder, their role as a supplier and as a processor are shown. After preparing the CPOC chart, the CPOC diagram is prepared, which is shown below, representing the roles and responsibilities of every stakeholder involved in our project. Cost of quality. Cost of quality can be defined as a cumulative cost required to reduce the poor quality services so that the product is brought up to the standard and specification. As you can see in the chart, there are four types of cost involved in the cost of quality. The first is the prevention cost. For this project, the prevention cost includes the cost of QC labs equipment. The total prevention cost is around rupees 93,000. The next cost is the appraisal cost. The appraisal cost includes the cost of calibration of QC labs equipment, cost of QC personnel salary at site, cost of third-party testing, and cost of setting up the QC lab. The total appraisal cost comes around rupees 12,93,000. The third cost is the internal failure cost. For the internal failure cost, I have identified two non-conformities at our project site. The first non-conformity was honeycombing and lower strength of 6 columns, where all the 6 columns were demolished and reconstructed. Their cost breakup is shown in the right hand side pie chart. The total cost was around rupees 51,000. As you can see in the pie chart, 61% of cost was due to concreting, as all the columns were demolished and reconstructed. The second non-conformity was improper patchwork in the beam, which is shown in the figure. The cost breakup is shown in the form of pie chart in the right hand side. As you can see in the pie chart, 38% of cost involved is due to mixing of micro concrete with multipurpose stirring machine. The total cost of non-conformity 2 is around 7,000 rupees. Planning reinforcement. The project is divided into two pores for each floor. For pore planning, firstly, I have calculated the total reinforcement requirement for entire project from the pore area and coefficient of steel. As you can see in the first chart, around 315 tons of steel will be required during the month of June, while 177 tons of steel will be required in the month of March due to major holidays like Holi and Dhuleti. Hence, the total quantity of reinforcement required for the entire project is calculated. The next is the manpower requirement. Here, the productivity of each team is taken as 122 kg per team per day. It has been assumed that one team consists of one fitter and one helper. From the chart, we can infer that peak requirement of manpower is in the month of June, where 88 teams will be required. Next is the staking, bar bending and cutting area. So the project site is divided into three areas for staking of reinforcement. Here I've calculated the total area required for the peak month, which is June 2022, where 315 tons of steel will be required. The weight of one bundle is 9 tons. Total 35 sets will be required. The area of each set is 12 square meter. Therefore, for 35 sets, 420 square meter of area will be required. 25% of space is kept as a circulation space, which is 84 square meter. Hence, the total area required to store 315 tons of steel is 504 square meter. At site, 513 square meter of area is available to store the reinforcement. Therefore, even during the peak month, ample of space is available to store the reinforcement. Inventory management. Here I will discuss about simple EOQ model. Simple EOQ model consists three costs: purchase cost, ordering cost, and carrying cost. For the purchase cost, total quantity of steel to be used from February 2021 to February 2022 is calculated. Total 1,450 tons of steel will be required during this time period. For this quantity of steel, total purchase cost is around rupees 7 crore 69 lakh. To calculate the ordering cost, the salary of personnel involved at site is firstly calculated. Total ordering cost is around rupees 3,300. The last is the carrying cost. 5% of purchase price is considered into carrying cost. Total carrying cost is rupees 2,600. In the left side graph, we can say that at the intersection of ordering cost and carrying cost, the total cost is minimum and the quantity corresponding to that is 60 ton. Here, the most economical point obtained is 60 tons and the cost is around rupees 79,000. After calculating the cost as per EOQ model, I have compared the actual cost as per site and theoretical amount. As per EOQ model, total 3,943 rupees is saved if 60 tons of steel are ordered at an interval of 15 days with 24 numbers of order. Primavera risk management. Risk management can be defined as the process of identifying, analyzing, and responding to any risk arising from the project life cycle. For risk management, Primavera Risk Analyzer software is used. The scope of work is 8th floor slab of EF block. The slab is divided into Pour 1 and Pour 2. For the risk management, the first step is to identify the risk. The second step is to analyze the risk, and third step is to provide response and mitigation strategy. For this project, total 36 risks were identified, which are based on different categories like construction, finance, organizational, regulatory, and so on. Some of the important risks identified are shown in the below table. The category of each risk is mentioned. Also, their probability of occurrence, cost, performance, schedule is mentioned from the scale of very high to very low. The score of each risk is also mentioned along with the response strategy. The response can be categorized into four types: avoid, accept, reduce, or transfer. After following the above steps, some graphs were prepared. The first is the finish date distribution graph. This graph shows that the project has 36% of probability being finished by 8 July 2023. The earliest date for the completion of the project is 9th June 2023, while the maximum date by which the project can be completed is 14th August 2023. The next is the scatter plot for time and cost. As you can see, the two axes in the graph shows the finish date and cost of the project. The horizontal and vertical axis indicates that the project has 52% of success by completing it in 1 crore 77 lakh and 52% of success of completing by 12 July 2023. After preparing the graphs, the CPM and PERT method is compared. The table shows that the project is most likely to be completed by 8 July 2023 within 451 days with the probability of 36%. The most likely cost for the completion of the project scope is around rupees 1 crore 77 lakh, which has 52% chance being completed within budget. Foreman Delay Survey. Foreman Delay Survey is a lean tool used to calculate the productivity and performance of workers. The scope of work is 6th floor slab reinforcement work of E block. The time of observation was 11:30 am to 1 pm and 2 pm to 5:30 pm. We observed 4 helpers who were working on the reinforcement work of slab. One foreman was present who was guiding the helpers. The main aim of this survey is to identify the delays in the activity and to provide the suggestive measures to avoid such delays. There are two types of delays: supportive delays and recoverable delay. The sequence of main activities observed at our site is shown in the below diagram. For the slab reinforcement work, the helpers were marking the length of slab according to drawing. Next is the lifting bars from the stake of reinforcement. Next is placing bars on the transverse side, placing those bars on the longitudinal side, and providing the cranks on the longitudinal and transverse side. After observing all the helper, their delays were calculated. As you can see in the graph, 14.3% of delay was caused due to travel time and 1.3% of delay was caused due to wearing safety gear. Next is the cost incurred in delays of 4 helpers. From the chart, we can infer that out of all the 4 helpers, helper 1 has the highest salary for non-working man hour, which is rupees 188, while helper 2 has the highest salary of rupees 171 for productive time, which is salary for working man hours. From the graph, we could see that helper 2 is the most productive and efficient helper amongst all. Conclusions and key learnings. Triple role concept. Triple role concept helped us in understanding the dependency of different stakeholders on each other. It explained us how the role of each stakeholder to be involved during the process can be identified with improved coordination even before the project begins. Cost of quality. If investments are made earlier in terms of prevention and appraisal cost, it would help in attaining zero defects. Later from site, 2 non-conformities were identified and their cost incurred were detailed. The total cost of non-conformity 1 was estimated rupees 51,000 for 6 columns. The total cost of non-conformity 2 was estimated rupees 7,700. Poor planning, reinforcement. The peak quantity for reinforcement was studied. The highest requirement of reinforcement was found to be in June 2022 of around 315 tons of steel. The manpower required for reinforcement works during peak time was calculated. As per calculation, 88 teams must be deployed to complete the work on time during peak time were inferred. Inventory management, simple EOQ model. As per the simple EOQ model, the total quantity of reinforcement is 60 tons with an optimal cycle time of 15 days and 24 numbers of orders. After comparison of theoretical and actual scenario on site, total saving as per simple EOQ model turned out to be rupees 3,900. Primavera risk management. We understood how identification of risk in earlier stages can help in preparing mitigation strategy to minimize or eliminate the impact of risk on project. Also, how different forms of interpretation can be shown in the form of graphic study. Here, the most likely or deterministic duration for 8th floor of block EF is 451 days. Cost is rupees 1 crore 77 lakh and finish date is 8 July 2023. Lean construction Foreman Delay Survey. We observed 4 helpers who were working on the slab reinforcement of 6th floor of E block. Total delay caused by each helper were shown, where 14.3% of delay was caused due to travel time, while 1.3% of delay was caused due to wearing safety gears. Also, the cost incurred in the delays were studied and productive time amongst all the workers were shown.